Hello students, how are you? Here is my first class and today I am starting ray optics. You have learned optics in class 7, 8, 9, 10. Okay. So in class 12 uh, I am starting optics with refraction of light. It's a very important topic of light. You know, light always travels in straight line, right? But if any obstacle come whose size is near to light's wavelength, then light doesn't travel in a straight line. That you will be learned in wave optics. Ma'am has already started, I think. Okay, okay. So you know that light always travels in a straight line. Okay. Second thing, very important thing, that reflection of light, and the third important topic is refraction of light of ray optics. Okay, so today I am starting that thing. Refraction of light is that very easy bending of light rays when it passes from one medium to another medium with different optical density. What is it? Bending of light rays when it passes from one medium to another medium with different optical density. So one term is coming, optical density, right? So two medium is there. One is optical denser medium, optically denser, and one another is optically rarer. Okay. Medium in which light travels slower, that is optically denser medium. Suppose light is traveling from one medium to another. When it is coming to optically denser medium, it will travel slower. Okay. Next, medium in which light travels faster, that is optically rarer medium. So in optically rarer medium, the light travels faster. In optically denser medium, the light travels slower. Very important thing, keep it in mind. Okay. Next, how to measure optical density? You know that is one term is there, optically denser medium, optically rarer. But how to measure it? Now that term is coming, refractive index. By the refractive index you can measure it. So it is denoted by mu, that is called mu, that particular symbol that is called mu, it is denoted by mu, that is refractive index. Okay, mu is equal to c by v. C is speed of light in air and v speed of light in medium. Speed of light in air is c and v is speed of light in medium. Okay, understood that thing? Okay, so refractive index depends on the speed of light in the medium, because mu is equal to c by v. V is speed of the light, and speed of light in air or vacuum is always constant. C, that is c, speed of light in air or vacuum, that is always constant, because it will be same in air or vacuum, it will be same, but it will be different in different medium, that is v. Speed of light will be different in different medium, that is v. So refractive index is always depending on the speed of light in medium. Okay, okay. So mu is greater when speed of light is lesser in that medium. When mu is greater, then speed of light will be less in that medium. Getting my point? When mu is greater, then the medium is denser. When refractive index is greater, then the medium is denser. Okay, so that is the feel of refractive index. Getting my point? Okay, so refractive index is more there in a medium, the speed of light will be decreased when there refractive index is more there in a medium, the speed of light will decrease. Okay. Okay. Suppose refractive index of a medium is 2.5, there is 2.5. Okay. So you can write 2.5 is equal to C by V, that is the refractive index. So from here you can write V is equal to C by 2.5, isn't it? So in that medium the speed of light is 2.5 times lesser than the speed of light in air or vacuum. You can say it. So from the refractive index you can say the speed of light. You know the refractive index of that medium 2.5. So you now can write out the speed C by 2.5. So in that medium the speed of light is 2.5 times lesser than the speed of light in air or vacuum. Getting? Refractive index in air, how to find? You know mu is equal to C by V. So C is speed of light in vacuum or air and V is in speed of light in medium, but now I am asking for air. So that is also C. So C by C, that is 1. So refractive index of air is 1. Okay, understood? Okay. Now we are taking this refractive index of air 1 and then compare the refractive index of other medium with light. Okay. Suppose refractive index of glass is 1.5. So it's 1.5 times denser than air. Yes or not? Okay. So speed of light in glass will be 1.5 times lesser as compared to air. Speed of light in glass will be 1.5 times lesser as compared to air, because in air or vacuum speed of light is maximum. Okay. So we are comparing this refractive index with air. This refractive index is called absolute refractive index. Okay. Suppose refractive index of diamond is 2.4. So diamond is 2.4 times denser than air. So speed of light will be 2.4 times lesser in diamond as compared to air. That term, that refractive index is called absolute refractive index. So what is the absolute refractive index? When the light ray passes from vacuum, in practical air, into a medium, then the ratio of sine of angle of incident to the sine of angle of refraction is called absolute refractive index of the medium. It is denoted by mu. Absolute refractive index mu is always greater than 1. So understood that point? I think it is clear. Okay. Next, coming to bending of light. There are two diagrams. In the first one, there are two mediums. One is mu1 refractive index, another mu2. First one is rarer medium and this one denser medium. So mu2 is greater than mu1. That is the diagram. This is the incident ray and this is the incident angle and this is the refracted angle, that is R. Okay. You can see in the first diagram, when light coming from rarer to denser, light bends towards the normal. When light coming rarer to denser medium, then it is bending towards the normal. Yes or no? It is bending towards the normal. Okay. In the next picture, in the next diagram, you can see First one, mu1 is denser, refractive index mu1, denser medium, refractive index mu2, that is rarer medium. So mu2 is less than mu1. Here you can see that light bends away from normal, away from normal. So when light travels denser medium to rarer medium, it bends away from normal. And when light travels rarer to denser medium, then it bends towards the normal. That is the bending of light. Two cases where light doesn't bend. What are the cases? First one, in the case of normal incidence, where I is equal to 0, refractive angle of incidence I is equal to 0, and angle of refraction R is equal to 0. That is normal incidence. In case of normal incidence, so there will be no bending of light. Another one, when mu1 is equal to mu2, that means refractive index of first medium is equal to refractive index of second medium, then light will go straight, no need of bending, because refractive index is same. So medium is same, so light will not bend. So these are the two cases where light will not bend, light doesn't bend. Understood? Okay. Next, you can see here, that is the picture, that is the normal, this is the normal, and there are two medium, one is mu1, another is mu2, one is rarer and one is denser, and speed of light in the first medium is v1, second medium is v2. So you know mu1 is equal to c by v1 and mu2 is equal to c by v2. Okay. So from here you can write this mu2 by mu1 is equal to c by v2 by c by v1. So from here you can write mu2 by mu1 is equal to v1 by v2, or mu2 by mu1 can be written like that. This is, what is it? Refractive index of second medium with respect to first medium. Okay, mu2 by mu1 also you can write like this, that is called refractive index of second medium with respect to first medium. First you have to write 1, not 2, don't make any mistake like that. First 1, then mu, then 2, that means refractive index of second medium with respect to first medium. Okay, so mu2 by mu1 is equal to v1 by v2. From here you are getting this term. Okay, now if v is equal to f lambda, you know v is equal to f lambda, where v is equal to speed of wave, f is the frequency and lambda is the wavelength. Okay, v and lambda depends on medium, v and lambda depends on medium, but f depends on the source, it doesn't depend on the medium, depend on the source, from where source has been produced. So it is depending on the source f, but v and lambda depends on the medium. So from that equation you can write refractive index of second medium with respect to first medium is equal to mu2 by mu1 is equal to v2 by v1 is equal to v1 is equal to f lambda 1 by v2 is equal to f lambda 2, f cancel, is equal to lambda 1 by lambda 2. So mu2 by mu1 is equal to lambda 1 by lambda 2, that is another relation. Okay, very important relation. Okay, understood? Next, coming to laws of refraction. Okay, first law, the incident ray, normal and refracted ray lies in the same plane at the point of incidence. That is very easy one. Incident ray, normal and refracted ray lies in the same plane at the point of incidence. Very simple. Second law is coming, Snell's law. Okay. Suppose there are two mediums, medium 1, mu 1, medium 2, refractive index, mu 2, that are the incident ray, incident angle I1, refracted angle R1. In second case, incident angle I2, refracted angle R2. In third case, incident angle I3, refracted angle R3. Okay. What Snell's law says, actually in the case of reflection, we knew that I is equal to R, right? So angle of incident I is equal to angle of reflection R. In the reflection part, we knew that thing. But here we need to find the relationship between I and R. In case in the topic refraction, we need to find the relation between I and R, just like that reflection, but there was no relationship. So scientists are just finding the way out. Then this came, that is sin I1 divided by sin R1 is equal to sin I2 divided by sin R2 is equal to sin I3 is equal divided by sin R3 is constant. That means angle of incident I1, that sine of I1 by sine of R1 is equal to constant. Okay. Understood? If the pair of the medium is same, one thing, if the pair of medium is same, then sin I1 by sin R1 is equal to sin I2 by sin R2 is equal to sin I3 by sin R3 is constant. Most interesting fact, that is sin I1 by sin R1 is equal to sin I2 by sin R2 is equal to sin I3 by sin R3 is constant. Okay. But also it is equal to mu 2 by mu 1. Sin I by sin R is equal to mu 2 by mu 1. Okay. So from here you can write it, mu 1 sin I is equal to mu 2 sin R. That is Snell's law. Very important relationship. Understood? Okay. Next we will do two numericals. That is, first one, a narrow beam of light is incident from air into a smooth glycerin surface at an angle 40 degree. Find the angle of refraction if the refractive index of glycerin is 1.473. Here you know the angle of incident I is equal to 40 degree. Mu 1 air, so 1. Mu 2 has been given. So mu 2 by mu 1 sin I by sin R. So you have to put the values here. So if you know this relationship, then you can easily find it out. No problem here in this question. Next, a light beam of wavelength 589 nanometer travels from air into another medium such that the angle of incidence is 60 degree and angle of refraction is 35 degree. Find the refractive index of the material of the medium and the wavelength of the light in the second medium. So here angle of incident has been given 60 degree. Air refractive index mu 1 is equal to 1. You have to refractive index mu 2. R has been given, that is 35 degree. So lambda 1 given, that is 589 nanometer. I am transforming it into meter. So 589 into 10 to the power minus 9 meter. High given, R given. So that relationship mu2 sine r is equal to mu1 sine I. Okay, so mu2 is equal to mu1 into sine I by sine r. From here I am getting the value of mu2, that is 1.51. Okay, now I know, you know, mu2 by mu1 is equal to lambda 2 by lambda 1 by lambda 2. Mu2 by mu1 is equal to lambda 1 by lambda 2, or from here you can find the value of lambda 2, that is lambda 2 is equal to 390.06 into 10 to the power minus 9 meter. So that is the very easy numerical. Practice all the numericals. That's all for today. Till then, stay safe, stay at home. Thank you so much.